Hello, I'm here to help you find the curvature of r of t is equivalent to t squared, comma ln t, comma t ln t at the point 1, 0, 0. So if you recall, the formula for curvature is the following. R prime t, the magnitude of r prime of t cross r double prime of t divided by the magnitude of r prime of t cubed. So let us find for the r prime. Let us find r prime of t. So the derivative of t squared, simply 2t. Derivative of ln t, simply 1 over t. The derivative of t ln t will consist of product rule. So let us do it. So the derivative of ln t is 1 over t. Keep the first, so that'll become t over t plus derivative of the first should be 1, and we keep the ln of t. So t divided by t is just another way of saying 1. So let us write down 1 plus ln of t. So this is our r prime of t. Let us find the magnitude of r prime of t. Well, this will be everything in here squared. I'll square root it. So 2 squared, 4, t squared, 2, plus 1 squared is 1, and then t squared, t times t is t squared, plus 1 plus ln of t squared. So now that we have the magnitude of r prime of t, and the sentence is asking to find it at 0.100, let's solve for this when r given t is 1. So t 1 squared just be 1 plus 1 over 1 is 1 plus ln of 1 is 0. So we just have 1 there. So 1 squared is just 1. This will equal the square root of 6. And now we can cube this. So that will simply be 6 square root of 6. This is our r prime of t cubed. We'll be using that later. Let us find now the second derivative of r of t. So the derivative of 2t, simply 2. The derivative of 1 over t will be negative t to negative 2. And the derivative of 1 plus ln of t will simply just be the ln of t, because 1 is a constant. So 1 over t. This is our second derivative. Now what we do here is we cross r prime of t and the r double prime of t. So let's do that. So we have 2t, 1 over t, comma 1 plus ln of t, cross t, 2, negative 1 over t squared, and 1 over t. Okay, so if you cross this, you will end up with so if you cross this, we will have I is equal to 1 over t t squared minus or plus, that will be a minus 1 plus ln of t over t squared. Okay, comma, now we take it, not comma, minus j. Okay, so if you cross j, you get 2t over t, which we know to be just 2, minus 2 times 1 plus ln of t, which we can just write as 2 plus 2 ln of t plus k, which will be 2t over t squared, so that'll be negative 2 over t minus 2 over t. Okay, so from this, I will make more room. Actually, I will continue on the back here. So, you recall, we were doing r prime of t cross r double prime of t. Okay. So we had our r prime of t cross r double prime of t. Well, now let's continue back here. So we had a lot of things that could have been reduced. So if you look on the back, you will see that this cross, you see that this cross becomes 2 plus ln of t squared, comma 2 ln of t, comma negative 4 over t. Now we must find the magnitude of this. Okay. So now let us take the square root of everything there squared. So we have 2 plus ln of t squared over t to the 4th plus 4 ln of t squared, pardon me, t plus 16 over t squared. So that becomes the ln squared of t plus 4 ln of t plus 4 all over t to the 4th plus 4 ln squared t plus 16 over t squared. So now let us find this at point 1, as we did when we solved for r prime of t cubed. So the ln of 1, 0. Let me just, ln of 1 is 0, plus ln of 1 is 0, plus 4, all over 1 to the 4th, which is 1, plus ln of 1 is 0, plus 16 over 1, it's just 16. So all of that is equivalent to the square root of 20. So now, if we look back at our curvature equation that we wrote when we first started, we see that this is, the curvature is the r prime of t cross r double prime of t, the magnitude of, divided by the magnitude of r prime of t cubed. So here we have our r prime of t, and here we have it cubed, so we're going to be using this value, and here we find the magnitude of r prime of t cross r double prime of t. So here we're just gonna have square root of 20 over 6 square root of 6, which if you take out your calculators, you're gonna find is equivalent to roughly 0.3043. And this will be your answer. Thank you.